my very good guru. And
so some of the reportable diseases of animals. Uh, so this is some of the reportable diseases include plague, rabies, and that is to the health department, that is concerning with the human health. And those which are reportable to the animal husbandry department include anthrax, brucellosis, glanders, listeriosis, avian influenza, swine influenza, and many more. So we will concentrate today on brucellosis. So the next is the zoonosis. These are some of the bacterial examples of zoonosis. We have got anthrax, brucellosis, campylobacteriosis, leptospirosis, listeriosis, Lyme disease, and salmonellosis, out of which brucellosis is the most important of all the diseases, which we are going to look at from the veterinary perspective. So next we go to the zoonosis, which is based on animal diseases, on animal species. So among dogs and cats, we have got rabies, roundworm, some ringworm, Lyme disease, and cat scratch. And among the food animals, again, we see that brucellosis definitely takes up a big space, along with anthrax, listeriosis, leptospirosis, and salmonellosis. So these are some of the important zoonoses which we have to deal with in daily life. Some of the further zoonoses which we see are in birds, which include psittacosis, West Nile, cryptococcosis, salmonellosis, mycobacteriosis. And among wild animals again today, which is all the more very enigmatic, is the presence of brucellosis in wild animals along with hanta, plague, and tularemia. So today I will touch a little bit about wild animals because that is some of the most neglected area in brucellosis in our country. So we go to the next thing, that is what is transmission, diagnosis, prevention, and control. So now we look at the economic importance of brucellosis. So the first thing is, what is the main impact? Number one is it causes abortion. So the first loss is due to abortion because we lose the calf and we lose one whole term of the animal, one whole calving period. So again, it may land into multiple calving periods where this loss is and where this loss can be encountered. Then we have diminished milk production and contamination of milk. Then we have culling and contamination of infected animals due to breeding failure. Because once the calving interval is lost or prolonged, there is going to be diminished milk production, contamination of milk with brucellosis, and also culling and contamination of infected animals happens because you cannot keep these animals within the herd. They need to be isolated and ultimately contained because they never become brucella free. In human brucellosis, on the other hand, we see reduced work capacity because of the constant undulating fever, the joint pain, arthritis, etc., which give rise to a lot of reduced work capacity. Not only that, there is a lot of government expenditure on research and eradication schemes, and there are losses of financial investment, especially by the farmers. So research and eradication schemes are not very get a long time to get implemented. Once implemented in our countries, because we have got such a large country and not much of organized farming, so we have a lot of cattle in the village side who are roaming freely, and therefore it is very difficult to undertake a concerted eradication program. So for all these reasons best known to us, we are facing the problem of brucellosis. Now my main idea of showing this slide is in the One Health program, where you are seeing on one side there is human brucellosis and the other side the animal brucellosis, and we are seeing a lot of problems as far as public health, veterinary public health, which we can see here, and also the human public health. So we'll find out all these in the as we go ahead in the lecture. that these 6 points are that those 6 points are of great importance to us. Now, just to have a cursory glance at some of the important Brucella species, there are about 10 of them which I have mentioned here. But I would like to stress upon two very important ones, that is, as far as public health is concerned, is Brucella melitensis and Brucella suis. Now, abortus, ovis, canis, neotome, microti, maris, pinnipedalis, setae, they are all known to cause disease in cattle, sheep, goat, and respectively in sea animals. But what we find here is in melitensis, the human disease is severe, so also in case of Swiss. So these are the two biovars which are biovars of these which cause severe disease in humans. And also we have got the other diseases like canis, which is benign in dogs, but at the same time the dogs cannot reproduce after that. So therefore all these diseases are important. Now what is very characteristic are the last last 5 or 6 species starting from number 6 to 10, where we can see that nothing is known about the human disease, neither about the transmission. Only these have been isolated from wood rat, dolphins, etc. But we do not know the extent of how much they can affect human beings who are in contact with these animals. Because you see, dolphins and other sea mammals are used as show animals in places like Singapore and other places. So it is very important to know whether these are also carrying these organisms. So they do not suffer from the disease, but they do carry these, and we do not know what is the type of human disease that can be caused. So this is the main reason why I showed you the slide about these different organisms. Now just to touch upon the zoonotic cycle in brucellosis. Yeah. So this slide I think many people have seen. I mean all students must have seen so far. My idea is to show you that how it remains in a particular niche. So you see these are the niches. This is niche 1, this is niche 2, 3 and 4. So we have got 4 important niches in nature. So we have got these 4 very important niches in nature. You can see about the swine, dogs, goat, sheep and cattle. And these 4 niches are very important as far as transmission to human beings is concerned. So here you see that the human being is in the final or is the end host and is always on the receiving end as far as these organisms are concerned. But how to remove the organism from these populations, from these niches, is the biggest challenge which the veterinarian is facing today. And even with the best of control programs in place, it is almost a very difficult task to remove all these niches or to clear these niches of these organisms. So today's topic that in One Health program, I should say the difficulties which are encountered by veterinarians and public health specialists is just this slide. This slide speaks volumes about how these niches are present and what best can be done to remove them. Now, there are 2 things which are shown. One is vaccination, and of course, vaccination is something which we are doing in animals, not in human beings. But at the same time, these pills are also very important. So this is again a very big risk factor. This one thing is a 5th risk factor to the human being. So we have got 5 risk factors to the human being, and these risk factors not only are risky for the human being, but also for the animals which are present, in the population. So this is one of the very important aspects of which I wanted to show. And as we go further, you will see why this slide has so much importance. Now we just go to the next slide, that is about the risk factors. So the risk factors in animals, first we have the animals, sorry, the previous slide. Yeah. So we have got these risk factors first one is animal to animal transmission. Just think about the previous slide. So here we have got, so we have seen those 4 niches earlier in cattle, sheep, goat, swine and dogs. So here we have got animal to animal. Now how does the organism remain within the niche is very complicated. Number one is through the oral route, because the aborted contents or the excreta of the infected animal can contaminate the bedding, the pastures, and that is how the organism can enter through the oral route. It is also through contamination of the udder during milking. That is once, if no proper biosafety or standard hygiene precautions are followed, and which is generally not followed. So therefore, udder contamination during milking, contact with aborted fetuses and newborn lambs and kids is again a very important problem. There is also venereal transmission of the disease, and among the populations, that is between say sheep and goat and to the dam, and also between the bulls and also between the pigs, within the sire, within the boar and the sow, and between the dogs, within the dog, that is from the male dog to the bitch. So these are the venereal transmissions which occur in these 3 niches. And the fourth very important point is about AI, because in cattle we definitely do AI, and that is why semen contaminated with brucella is another very important risk factor. So these are very important risk factors as far as the transmission is concerned. The next one is very important, that is from domestic to wild animals. Although the prevalence of brucellosis is very low, or we do not have much recording or recorded cases of brucellosis in wild animals, the interactions between wildlife and livestock are very important. And what is their impact? Whether there is impact at all, we'll see in the coming slides. I will show it to you what may be the impact of these of this organism as far as the transmission between wildlife is concerned. Now we go to the next slide, that is animal to human transmission. Animal to human transmission is again a very important aspect. Now this can occur through infected tissues, while the veterinarian is handling infected tissues from the aborted fetus. Then contaminated materials by milk from affected animal, invasion through intact skin, inhalation of aerosols containing the bacteria, and also through the intact conjunctiva. So all these become very important risk factors as far as animals are concerned, animal to human transmission is concerned. Next we go to brucellosis in wildlife. Next we go to brucellosis. Yeah, we go to brucellosis in wildlife. Yeah, so in wildlife, despite their host preferences, Brucella abortus and Brucella suis have been isolated from bison, elk or red deer, feral swine and wild boar, red fox, European brown hare, African buffalo, reindeer and caribou. So these are the number of species, as you can see here, that these the organism abortus and suis have been isolated from all these animals. There are records, and one of that is from Godfroyd et al. 2013 in one of the articles in official that was in the OIE journal, and this is a very outstanding, or what do you say, a very worrisome view of what how the organism has spread into wildlife. Now this is why worrisome, because I showed you the 4 niches. Now we have got the 6th niche, That is, one is, of course, we have seen the vaccinations and others. Now this is another sixth niche which you can say. So now you will understand the enormity of the Brucella control program and whether it can really be effective as far as eradication of the disease is concerned. We have seen eradication of rinderpest, we have seen eradication of so many other diseases. But this is one disease which is really a challenge as far as the control is concerned. So this becomes our sixth niche, and this is a very important turn for the veterinarian, because wildlife veterinarians are also not very well equipped to understand the presence of these diseases in the populations. So we go to the next slide. So what are these risk factors? So the pathogenesis of Brucella species in wildlife reservoirs, I told you, is not fully defined. We still do not know much about how the organism remains within this wildlife species, because they do not show much of any symptoms, neither do they show any overt disease. Second most worrisome factor is that there is no vaccine against brucellosis that demonstrates satisfactory safety and efficacy in wildlife. Now this again is a worrisome factor when we talk about this very elusive niche, which is not very easily accessible to most veterinarians. Then transmission of Brucella species from wildlife to humans. Again, this again has a three-pronged transmission. Now you will understand how global is the spread of this sixth niche. We used to take wildlife for granted, right? We don't take much of interest, or rather we just look at it from the point of view of going and enjoying a holiday in the national park. But now when you look at this, you will see that in this sixth niche, there is a global involvement. Number one is the butchering of meat and dressing of infected or feral pig carcasses, mostly conducted in the developed world. That is, you see, they are very used to killing or hunting animals, game animals, and then, you know, just smoking the carcass, or just exposing it to some heat, and then eating it almost raw, you could say. So this type of one is a very important, very very important aspect of risk factors. Very important risk factor in the developed world, where they go into the jungles and they hunt animals and they eat so their carcasses, or they eat the meat, and some of time it's just smoked or just barbecued very lightly. Then next we go to is the infected African buffalo, which is of concern in the developing world. We have got the buffalo in our country, the Indian buffalo. We have got buffaloes in Philippines. So there are different varieties of buffaloes, but here I've just mentioned the African buffalo. Well, it can be Indian as well as those in the Southeast Asian countries. And this again is a very important animal where the disease is not overt. It does not show any much symptoms, maybe some abortion and delayed estrus, or it goes in for repeat breeding, and nothing much is known. So even in buffalo, the presence of Brucella abortus, the recordings of Brucella abortus is not always very clear. But however, we equate it to the bovine population. We equate it to bovines, and that is why we say, okay, there is Brucella abortus in buffalo. But again, that also is not very, very well recorded, except in few recordings in our country. We have got some studies in buffalo, which we did in our department also. And yes, we found the presence of abortus in these animals. Now look at the other niche. Now we look at the Arctic Circle. There is traditional consumption of bone marrow and internal organs of the freshly killed caribou or reindeer. So this is again in the temperate zone to the Arctic zone. This again is a very important practice, and it is a very big risk factor. Now you will understand that in these areas, the population of these people are very small. and most of the people die by the time they are hardly 40 to 45 years old. So that is why you find very few very old people in these areas, and that is because of the hard life, and also the number of diseases among what they die of is relatively unknown, and who knows whether brucellosis is there or not. So brucellosis, again, these risk factors, as we see, as far as public health is concerned, this is a very important risk factor. So in the sixth niche, we find that it is almost global. Well, the first 2, 3, 4 niches are very much under our control, but this sixth niche is global. It is there everywhere across the world, and this is what is making the eradication of this disease very, very difficult. Now, we go to the next slide. In this slide, I just wanted to show you. Yeah, I'm sorry for such a poor presentation. I hope all of you will bear with me. Brucellosis in wildlife, there are some very important questions to be answered. Number one, whether it is a result of a spillover from the livestock, or a sustainable infection in one or more host species of the wildlife. The answer is yes. It is there. It is very much there, and it is a spillover from the livestock, and a sustainable infection within the wild ruminants is quite common. So the answer is yes. Does the wildlife brucellosis represent a reservoir of brucella strains for livestock? At present, the answer is no, but we do not know in future when the organism does change or mutate. We do not know whether this may occur. But as of today, the answer is no. Is it of zoonotic concern? Well, maybe in certain situations it is of zoonotic concern. An example has been the presence of Brucella melanoensis from camel and its milk. When that camel was in contact with sheep and goats, especially in the desert areas in Rajasthan and other areas. Also, there are many other areas where the deserts are there. There is a presence of camels there, and melanoensis has been isolated. So again, transmission between species. Again, if there's such camel milk is consumed by the nomads or the Bedouins, this milk can cause brucellosis. Now, the next is the transmission from wild boar to pigs by venereal route. This has been shown as the presence of striped piglets, which are reported in France and Portugal. That means the wild boars which cross the forest area and come into the domesticated areas, they may reproduce through the venereal route. They may infect pig, sows, and the presence of cross-striped piglets have also been reported. So therefore, these diseases can be passed through the semen from these wild boars to the pigs. So we do not know how this cycle continues, and this is the fourth niche which I showed you, that within pigs, that is between wild boar to pigs, it is now a very well established route. So these are the very important niches, and these are some of the questions which need yet to be answered, though we have just given an answer in yes or no. Now we look at some of the possible solutions which may happen. So brucellosis in wildlife, some possible solutions are: number one is to resolve the potential conflicts between ecologists, regulatory veterinarians, the production animal industry, the hunting industry, and the public health authorities. Now you tell me that all these are one system to the other. So ecologists are their own system of their own. The regulatory veterinarians are on their own. The production animal, the animal industry, there's the production group is the different industry. The hunting, I told you, as they do in USA, you see hunting is allowed. So not in our country, but in USA it is allowed. So the hunting, there's an industry there, right? So all these, whether the potential conflict. Now, all these do not gel together, right? So they need to resolve the potential conflicts between themselves and only then coordinate with the public health authorities. Well, that doesn't happen. So that is becoming the biggest problem. The general approach to wildlife brucellosis has evolved from general diagnosis of brucellosis to include. So the approach to wildlife brucellosis has evolved from general diagnosis of brucellosis to include, number one, what needs to be done is to detect a preclinical or pre or subclinical infection within these animals. Early detection that could be done by a PCR maybe. Then identification of transmission routes between different host species at the livestock-wildlife interface. Now this means that this is at the border of the jungle. You see the sylvatic portion. So when you look at the border, so you see you have to identify the transmission routes. That means how the animals move. So animals have their own migration routes, and therefore transmission also occurs through these routes only. And therefore it is very important to keep an eye on this livestock-wildlife interface. And it should be aimed at taking preventive control and management measures. Number one is to decrease the number of interfaces between livestock, wildlife and humans and national parks. So this is something which is very difficult to be done. Now you have seen in our own Mumbai, the spillover of animals from the Sanjay Gandhi National Park into the residential areas is a very, very important glaring example of this. So whether we can really decrease the number of interfaces. Now there are some national parks like Kaziranga, etc., and also the Corbett National Park, where you will find that these national parks are huge. And there are animals who stray into these national parks. There are livestock. And these wildlife and livestock do come in contact with each other. And also there are human beings who are at that place because there are many settlements in that area. So therefore, all these create another niche, that is the seventh niche, which we should talk about. So what is the seventh niche? It is the livestock, wildlife and humans residing in one area near the national park. So this becomes another very important niche where the organism is again circulating. Now how to reduce the risk of brucellosis in both livestock and free-ranging captive wildlife should be now our biggest concern. And this is the only way which would minimize the potential for zoonotic transmission. So what we have to do, we have to reduce the number of people, livestock staying around the national parks, get them tested, make them free of the disease, and keep the free-ranging and captive wildlife again far from them, especially in zoos, etc. Before introducing in the zoo, the animal should be quarantined if it is brought from a national park, and the animal should be quarantined if it should be brought from a national park and tested for all diseases because before it is introduced into the zoo, because that is what is the captive wildlife. So free-ranging and captive wildlife, we have to reduce the risk of brucellosis in this interface, and therefore this will minimize the potential of zoonotic transmission. This will minimize the potential for zoonotic transmission. Now this particular slide is more towards how to manage the interface between the forest, the domestic wildlife and the human beings staying close by. Now this is a very glaring example because we are already facing this problem in our country in most of the national parks. And this is where we need to understand how to reduce this populations and reduce the chances and risk of brucellosis spreading into human beings. Now, why are lab tests essential? Because you may not be able to diagnose, because in animals it's very difficult. It's not possible that in wild animals you are going to get a very typical case. Typical case may not be found in wild animal at all. So to resolve the potential conflict, so why are lab tests essential? In an atypical case, the clinical diagnosis becomes difficult, so you need to understand and create, and also so you need to understand these atypical cases, and therefore regular testing, and that is through either captivating the animal and collecting the blood sample, or trying to find out its route of progress of migration, and then trying to collect some samples from the herd. A definite diagnosis can only be obtained by laboratory investigations. Otherwise, it may result in an animal remaining undiagnosed and a greater risk to human beings. So one test is not sufficient, so a battery of tests to be performed to arrive at a conclusive diagnosis. A positive test by one of the standard procedures may override the negative reaction in any other test. The negative tests do not rule out the possibility, of course, of the disease. So negative tests always do not rule out the possibility of the disease. So we have to at least do tests multiple times before we declare the animal negative. So it may be, so what are the type of tests which we can use? So you will say that now, if it is so difficult, then what are we doing today? So we'll see some of the most common laboratory tests. One is Rose Bengal. I think all of you know about it. You know the milk ring test. We have seen the standard agglutination test. We have seen ELISA, PCR. And we have also seen and we are also today looking at the lateral flow or nanodiagnostics. So these are the 6 type of tests which we can use. So the most preliminary test, that is a Rose Bengal, is used. Milk ring test is also being used by most of the basic primary laboratories. Standard agglutination test, of course, is now obsolete. No one uses it. Enzyme linked immunoabsorbent assay is expensive, but at the same time, it can give very targeted results. So therefore, ELISA is the test to stay along with RBPT. And of course, there is PCR, which is slowly trying to replace the isolation. The isolation of the organism is the gold standard, but we can adopt PCR in lieu of isolation. And let us look at the next test, that is lateral flow, which of course is very important as far as nanodiagnostics is concerned. So we'll have a just quick look as a qualitative test. It is very sensitive, especially in vaccinated animals. Positive samples need to be tested by confirmatory tests such as ELISA. So RBPT is a qualitative test, not very reliable, and therefore we need to also retest it by ELISA to distinguish between vaccinated and infected animals in the herd. Now this does not happen with RBPT. So RBPT is just an indication of whether antibodies are present or not. But if you have to distinguish between vaccinated and infected animals, today also you need to go in for an ELISA. There are some very good PCRs also, but ELISA seems to be already available commercially and can be used very easily for the DIVA test. Now, false negative reactions may occur and can be detected by retesting the animals at intervals of a period of at least 3 months. So negative readings may be there. So you need to retest these animals, because once the organism has entered into the lymph nodes, it has gone intracellular into the lymph node. Sometimes there may not be any antibodies present in the circulation or in the serum. And at that time, if the animal again gets pregnant, then again the organism may go towards the gravid uterus, and that is the time when you can retest the animal and find out the presence of the antibodies. So therefore, as I told you, a false reaction may not always mean that the animal is negative and should be again retested. Then we go to the next one, that is PCR. So we go to the next slide, that is on PCR. Now these are very preliminary. I just put this slide just to tell you that BCSP31 is the fastest and the most sturdiest PCR developed today. Any laboratory can do this PCR just to detect the organism up to genus level. Now you can do it from serum, you can do it from the blood, and also from the infected tissues. So all these need to be standardized at your level. I am not going into the details because this is not a diagnostic lecture. So I will not go into the details. So we have got the IS 711AB PCR for brucella abortus and the BM PCR for melitensis. So these two can be again used after the genus level identification for identifying which one it may be. And the real-time PCR is the most commonly used today. So if the first three are almost getting slowly obsolete, and what people are going in for real time simply because they can also find out what is the load of organisms in the sample. So that again gives you a much better idea about what would be the load of the organism within the samples tested in a population. So that is why population studies become better with real time as compared to the earlier PCRs. So this was all I wanted to tell you about this slide. So regarding PCR, that was all I wanted to discuss, simply because I just want to tell you that it is a real time which is very important when you need to do her testing and also to find out the load. Now the next one is the current methods. So we go to the point of care testing, that is lateral flow. So if you have a history of recent exposure, you can have isolation or you can do a PCR. Also serological methods may indicate high antibody titer. You can do ELISA. See, complement fixation and agglutination are not used, so but I just put it there for academic purpose. But otherwise, if there is a high IgG antibody titer, one can definitely say that the animal may be infected once you have done the DIVA test with ELISA. Now, the drawbacks of all these tests include they are invasive, they are quite slow, they take a few hours to finish. They may be non-specific, especially when you look at rose Bengal. Cross-reactivity is very common. You need a lot of skilled personnel and well-equipped testing facility. So all these are required when you have to do the conventional laboratory test. So all these can be avoided if you go for a point of care testing, that is using lateral flow. So that is why lateral flow tests are most preferred. So what are some of the advantages and disadvantages? We will see. The advantages, of course, far weigh out the disadvantages. So here we have got the accessibility is very good. It is very convenient. It gives rapid outcomes within a few minutes. The simplicity in usage is that you can take it anywhere on the field and do the test. You require very low sample volumes. That means you can collect it on small nitrocellulose, small paper, or on one of those grids. No sample processing is required, and it is portable. That means you just need to carry it in a small purse. So therefore, when you look at the home and community, it is very useful. It can be useful in a disaster or pandemic scenarios where you need to go to the field. And also it also reduces the burden on the laboratory diagnostician and also on the doctors who are going to remote and rural places where they need themselves to be first protected with PPE. So therefore, in these pandemic as well as in remote scenarios, doctors also are much assisted if we use a lateral flow. Hospitals, paramedical, primary care, healthcare centers, community pharmacies, all these can use this test. So you see the wide variety of usage as far as point of care test is concerned, and this one test can definitely be used, and it is a versatile concept that can be applied to all healthcare segments. So that is why the point of care test is a very important test as far as the diagnosis is concerned. Yeah. Now in this slide, why I took it after point of care test is because of the National Control Program on Brucellosis, which was launched somewhere in 2000, I think 2009 or 10. And this particular NCPP has two-pronged approach. One is the biannual village level screening of pooled milk samples and biannual Brucella abortus S19 vaccination for female calves between 4 to 8 months of age. So this was one of the main strategies which was being used. So we'll just see. So this is just the leaflet to show you how this program was first taken up from ICAR and the role of PDATMAS in the National Control Program on brucellosis. So we'll see what were the 4 main phases in which this program was to be held or is being held. The initial phase consists of sporadic testing of animals following abortion, usually for diagnostic purposes, followed by vaccination of some herds or flocks. So here the village is taken as the herd and all animals belonging to a particular village were taken as the herd. So that is the first phase. That is just sporadic testing. You just go around collecting samples, maybe aborted, non-aborted, whatever, and just collect the samples and just do the testing. The second phase consisted of intensive vaccination. So once it is tested, the area is tested, we know the number of animals which are positive. So intensive vaccination of the herds using Brucella abortus strain 19 or Rev1. So Rev1 was never used in India simply because of this transmission to humans. So that is why here please remove the, just don't consider Rev1. RB51 also never came in a big way in India. So it is still strain 19 which is doing its rounds. And strain 19 vaccination is still being done to vaccinate sexually immature or adult animals. So this is what is going on in the second phase. In the third phase, it was to test and remove. So segregation of infected animals, whatever infected remain, even after vaccination, those should be removed and culled, or rather they should be sent for isolation, because in India we do not slaughter cows. So the ultimate aim of developing brucella-free herds, so slowly over a period of time, when we vaccinate the calves and some of the heifers, what will happen is over a period of time, these animals will become immune and they will not get infected with the organism. So in a span of say 5 to 10 years, it was envisaged that almost most of the population where this program was being conducted, these populations will slowly become immune. So during this phase, vaccination is usually phased out towards the end of the eradication program. So therefore, slowly after removing all the infected animals, we create a brucella-free herd or flocks of animals where that is within the sheep and goat. But in sheep and goats, it was not possible to do it because of the risk of transmission to human beings. So therefore, Rev1 was not used. Now, fourth phase is the freedom phase, is the intensive surveillance. The intensive surveillance is to be maintained at least for 5 years to confirm that the agent is no longer present in the population. So you have to continue this surveillance for 5 years, and if you constantly get a negative IgG that shows that as far as the infective cutoff is concerned, then you know that these animals are now negative for the disease. So that again has to be done with the use of the ELISA, which differentiates between vaccinated and infected animals. So that is the ELISA which had to be used in this intensive surveillance program. Now why I showed you the slide on POCT is that in the initial phase, when you have to test milk samples, because milk and saliva, all these may contain the organism, and the lateral flow is specially designed even to detect the presence of brucella in the serum, in the milk and other fluids, that is urine, which are all non-invasive. So collection of these samples becomes very easy from the herd. One need not go around collecting blood because that again involves a lot of labor and intensive procedures. So that is why in the initial phase, if a lateral flow can be used, this will bring down the cost of the eradication program and also make it very easy for the veterinarian at the field level to carry out the test. Then we go to the, since we are talking about an eradication program, just want to specify some important parts of a brucella vaccine. It should give solid and durable immunity. It should not interfere with the diagnostic test, and that is why I told you the differentiating ELISA. The differentiating ELISA is very important. No limitation of its use, that is, it should be used in pregnant animals and should be safe for the veterinarians when performing the vaccination, and should not be very expensive and readily available worldwide. Well, this looks very nice and very informative, but let me tell you, till now we do not have a single vaccine which conforms to everything. So therefore, we have to do a combination and try to create as much immunity as possible within the ruminant population. So when we look at this types of brucella vaccines, so vaccination will increase the animal resistance to systemic infection, and this decreases the probability of placental infection, abortion, and massive shedding of infectious organisms. So this is one very important aspect which is to be considered when using a vaccine. Live vaccines like S19 will induce a long-lasting immunity and therefore administered to calves 4 to 8 months of age. Adults can also be vaccinated with reduced doses by conjunctival route in order to restrict the serological response. That is in adult animals, we can use this vaccine in reduced doses by conjunctival route and also to restrict. So some type of nano vaccine or sprays are designed and they may be used. So the following are the recommended vaccination for Brucella abortus and Rev1, that is Brucella melitensis. So S19 is very important. The freeze-dried live abortus strain S19 for cattle at 3 to 6 months of age, and in case of by conjunctival route in adults by reduced doses. The disadvantage is that it gives a persistent serological response, and it may create abortions in pregnant animals and a human risk if not taken with PPE, if not given along with PPE. Now, the freeze-dried RB51 can be used at 4 to 12 months of age as a single subcutaneous dose, but does not produce persistent antibody titers. But RB51 is not very easily available in our country, and there were some issues for which RB51 is not used. But all the same, I would like to just stress a little points about the RB51 vaccine. It is as efficacious as Brucella strain 19, but less abortogenic, does not produce any clinical signs after vaccination, does not produce a local vaccination reaction. It can be cleared from the bloodstream within 3 days, not present in the nasal secretion, saliva or urine. So this is the biggest advantage of using the RB51. It does not, the immunosuppression does not cause recrudescence. That means there is no reversion to virulence, neither the animal develops the disease. It is not spread from vaccinated to non-vaccinated animals, which is seen in case of S19. And it is safe for all cattle over 3 months of age. Now, with all these advantages also, the vaccine is not very readily available. So therefore, we still cannot use this vaccine. Now, as far as Rev1 is concerned, it is not used in India. Again, there is a risk if given to pregnant animals. There is a human risk involved. So therefore, it is not used. Now, what is the alternative? The alternative is to use a nano vaccine. Now, this nano vaccine can be prepared in a liposomal formulation. Liposomal formulation using mannose through a polyethylene glycol spacer conjugated with Brucella ovis antigen. So that could be one. And it is able to trigger a strong humoral response in mice. And also it has been checked in rams up to 6 months. And in addition, it was able to generate specific interferon gamma secretion after vaccination in rams. And it is a strategy to be explored for dendritic cell targeted vaccination of animals. So nano vaccines can be now designed for sheep and goat, because that is the only way we would be able to give a large herd, because you see sheep and goats are herding animals, and therefore nano vaccines given through say spray route would be much better, because it would be better because dendritic cell responses are much more stronger if you look at the vaccine immunity. Then that was about vaccines. Now we come to some new treatment strategies. Now, vaccines so far have been working, and well, side by side, we have the control program, we have the vaccination program, but again, still a big question mark. So, what is the importance of the new treatment strategies? Why people are still thinking of treating animals? Simply because once brucella, it is always brucella, and once the animal is brucella positive, it is going to be brucella positive for life. And therefore, to save the animals, we need to first devise a good treatment strategy. Now, there are many drugs which I'm not going to highlight in my topic today. So there are few ways in which these drugs could be administered. One is the whole drug, which is being tried out in large animals with little success, not much successful, because it's a very long, prolonged treatment. It has been tried in sheep and goat, but again fails to give the desired result because the treatment is too long, so it becomes too expensive. Next, we look at the liposomal delivery of these drugs. Well, that was again a very important way in which we could deliver the drugs to the liposomes. Again, the uptake of the drug remained a question mark. Then we have the nanoparticulate drug delivery systems targeting the infected RE cells. Well, this study is going to stay, and a lot of work is being done by many laboratories all over the world, including India. We had some work which we did with tuberculosis, and now Dr. Gandge is also going to do with NPDDS targeting infected RE cells. So this particular work with this particular strategy, if it works in the efficacy studies, that means if it is efficacious in laboratory animals, that is in the brucella animal model, and further efficacy when can be studied by doing clinical trials in infected animals, then of course we can say that the NPDDS targeting of infected RE cells may be used. Well, in tuberculosis, it was tried out in monkeys, this NPDDS strategy in infected monkeys, and it showed a clearing of the lungs after treatment. That is intravenous treatment. The only thing is these drugs have to be given intravenously. So that is one thing which we need to work on, because these drugs cannot be administered through the nasal route. So therefore, these new treatment strategies again are to be tried out, because this will play a major role in public health. If the animal can be treated, then definitely it would be a landmark in the history of brucellosis, because treating an animal for brucellosis is one very, very important strategy which needs to be addressed as fast as possible. So this definitely would be a very, very turning point in the One Health program in brucellosis. Now, what else do we need? Well, we have got vaccination, we have got diagnosis, we have got treatment. Now, this is very important, because we need to survey the zoonotic diseases, that is brucellosis. So, what is required? Number one is we need public. Number one, we need public health labs or mobile public health labs. We need to deal with all risk factors, that is food, water, etc. So setting up biosafety level facilities for handling of brucellosis. So there is one in the VPH department in Bombay Veterinary College. So that is one very important step towards, trying to study in zoonotic diseases, because without a biosafety lab, it will be difficult to address, especially the diagnosis and the isolation and identification of brucellosis, and also to work with even the DNA. One would require a good biosafety level, at least 3 or 4. Then establishing reliable labs at regional areas for early detection and reporting of cases. That means the primary labs. Then Rapid epidemiological investigation, so good epidemiological laboratories, that is the secondary labs, that is like disease investigation sections who would be doing a rapid epidemiological investigation, having rapid laboratory diagnosis of the disease in the preliminary labs as well as in the tertiary labs, and implementation of the effective control measures once all these are in coordination. And I told you that to coordinate ecologists, public health specialists and others, and government forest officials, and all the people together. So implementation of effective control measures can only be taken once we have a good coordination between all these authorities. So this is one very important aspect which is important as far as public health is concerned. The next very important aspect is the new technology for disease mapping by the global positioning and the geographic information systems. So to determine the ecological risks, I told you it is very important to have ecologists with you, because who is going to study all the environment and the migration patterns, etc. So to study the migration patterns, you need global positioning system, you need very good geographic information systems, so you need very good satellite systems to help. So you need very good satellite systems to help you understand the ecological risk factors of zoonotic diseases, especially in brucellosis, because it involves migration of animals, migration of wild ruminants, wildlife. And these new methods can enhance the most important components of a zonal surveillance system and environmental data collection. So all these are very important as far as the disease mapping is concerned. So even in our country, using satellite systems, it could be definitely enhanced, because just to have your app on the phone is not sufficient, but to link it to several positions, to several data. So to link all this data, you need very good GPS and GIS systems. So other than just having apps, it is also important to link these apps through positioning systems, so that you know that from one area to the other, what is happening, how animals are moving, and at the same time, you also know the extent of the disease in that area. So these new technologies for disease mapping is also a very integral part of One Health program. So therefore, so all these are very important as far as the One Health program is concerned. So One Health is not just necessary health, but it involves everything, right from technology, that is, you need computer science technology, you need disease mapping, which is through computer science technology, you need information technology, you need veterinarians, you need public health specialists, you need ecologists, you need wildlife experts, you need the works. So all these are needed to enhance your program. So I would like to conclude my talk with these few points, that brucellosis is the most common zoonosis. We have been hearing it for the last maybe 300 to 400 years. And the role of wild animals can never be overemphasized. Today's world, the sixth niche, among all the five, there are 5 niches. The sixth one is the wild animal, and we can never overemphasize that these animals are part of our ecological system. We need to recognize all the associated risk factors which I just explained to you. And then once you have identified all these, you need data and warning systems through good GPS satellite systems. You need good apps. You need all these data and warning systems which will help you to, which will guide the veterinarian and the others to go to the area and take up a quick response. Quick response team should be there, especially in disaster management. So you need disaster management in place, especially where there are epidemics of these diseases or enzootics occurring. It is a sporadic there, but the organism is very much enzootic. Then following up with good diagnostic, preventive, and therapeutic I put in question because still therapeutic in animals is still there. So such a need to be addressed. We need to find out better drugs. We need to find out better nanoparticulate drug delivery systems and also very good vaccinations. So nano vaccine, nano drug for follow-up along with good diagnostics. And last but not the least, a good coordination between veterinary and public health specialists is the need of the hour. But along with that, ecologists and other wildlife officials, forest officials, zoo officials, all these need to all sit together, have a roundtable discussion on how to eradicate this disease. The control program is in place, strategies are in place, but the people need to sit across and discuss and come out with the best solutions. So with this, I end my lecture today. So I thank you all very much for your patience. I'm sorry for a very sloppy presentation because my speaker seems to be going on and off all the time. My speaker went on and off all the time. I am really, really indebted to all the participants who bore with me throughout this entire lecture. I am extremely sorry for this very slow and sloppy presentation, but I just couldn't help it. I hope I am able to um, express the need for the One Health concept. I hope I was clear to you. I thank you again very much. That's why I've written here for your main patience. I thank the organizers also for their patience and they have shown me. Thank you all very much. Thank you. If there are any questions, I would be delighted to answer.
Yeah, thank you very much, madam. Actually, you have covered details of whatever lecture is being that professional additional and charge HOD Department of Microbiology, State GS Medical College and KM Hospital, Mumbai. She has completed her undergraduate, that is MBBS degree from Utkal University, and she has done her master MD microbiology from Mumbai University, and she has been actively involved as in various activities as joint secretary, Hospital Infection Society, Mumbai Forum. She is a member of KM Hospital Infection Committee. She is a trustee, Diamond Jubilee Society Trust, KMH, and she is an executive committee member. She is an executive committee member in institutional committee. She is a reviewer for national and international journals, and she is organizer for CMEs and workshops. She has been published several peer-reviewed those articles in national and international journals. She has been teaching undergraduate courses since 25 years, and she has a 15 years experience in PG microbiology teaching. The other research area of Lona Dash Madam includes hospital infection control, in which antimicrobial resistance, diarrheal diseases, salmonella infection, and fungal infections are her area of research interest. And Madam is actively involved in other activities of department and hospital and etc. So with this biodata, I request Dr. Lona Dash Madam to give today's speech on foodborne leptospirosis, its prevention and control. Lona Dash Madam, please.
Thank you, Dr. Radishri. Very good afternoon to all. At the outset, I would like to thank Dr. Zende for this beautiful opportunity to be among this august audience. And thank both of you and the team for this. To begin my talk, I will be talking on uh, importance of leptospirosis and its prevention and control. Dr. Rajesh, am I audible, please?
Yes, ma'am, you are audible. Please proceed.
Am I audible?
Yeah, yes. Madam, you are audible. Hello?
Am I audible, please?
Yes, madam, you are audible. Yes.
Thank you so
Your
much.
voice is clear. Yeah.
So very happy to be part of this August gathering. And I'll be talking to you under the following headings about introduction, classification, epidemiology and natural history of leptospirosis, modes of transmission, clinical features, laboratory diagnosis, treatment, prevention and control, and any future direction. We are all acquainted with One Health in this forum, and it helps us to understand and the importance of the connection between the health of animals, our environment, and human health. Thus, it helps to prevent outbreaks, improves food safety, and reduces antibiotic resistant infections and protects the global health security overall. Leptospirosis has been known since many years. About 100 years back, Adolf Bale in Heidelberg discovered the first case of icteric leptospirosis with renal failure. A similar syndrome had been reported in sewer workers several years earlier, which is also documented. The importance of uh, the rice field workers and infection was also known in China even before that, and cases had also been observed acute febrile illness among the Chinese miners. At present, leptospirosis is presumed to be the most widespread zoonosis in the world. It is ubiquitous and it is caused by infection with pathogenic Leptospira species. What about the spectrum? It can cause human disease in either from no manifestation at all, which is called subclinical infection, to a severe syndrome of multi-organ failure and death. The importance of occupation as a risk factor was recognized early. The role of the rat as a source of human infection was discovered in the 1900s, while potential for leptospiral disease in dogs was also recognized. Subsequently, the importance of leptospirosis among cattle and livestock was also brought into the public awareness. Again, the importance of leptospirosis in the milieu of post-deluge Mumbai cannot be overemphasized. In the year 2005, post or after the huge flooding due to the heavy rains, we saw a rise and a heavy rise in the number of leptospirosis cases in among humans during the post-deluge phase. In India, besides Mumbai, the coastal districts of Andaman and Nicobar Islands is well known for being endemic for this infection. Other states include the coastal areas of Gujarat, Kerala, Maharashtra, Tamil Nadu, followed by Andhra Pradesh, Karnataka, Dadar and Nagar Haveli, Daman and Diu, Puducherry, Goa, and Odisha. Basically, the coastal areas are the ones which are definitely affected. While going through literature review for this talk, I found this particularly interesting study of persistence of Leptospira cerovar hagium in the refrigerated raw milk, where it was considered that because it can remain for long periods, at least up to 7 days in the raw milk, refrigerated raw milk, it can be a source of milk can be a source of transmission of leptospirosis to humans from animals. This is what the leptospira organism, which is a very slim, slender organism with regular regular curves, and it is hooked at both ends. This is what it looks like. We cannot pick it up in the regular microbiology states. Need special methods for its diagnosis. Classification. The leptospira consists of mainly two important species. The pathogenic species is Leptospira influens, which has again further divided into serogroups and pathogenic serovars, which and this is the one which has potential for both animal and human disease. The other species being the saprophytic one, spider pyramids. And these are the various pseudovards and pseudo interacted among them. Coming to the natural history of Leptospira, basically an important interaction and between the environmentally favorable conditions like a suitable host, optimum temperature, water which is not polluted with sewage and non-saline and alkaline pH are all conducive to the survival and growth of Leptospira along with heavy rainfall and a bad drainage system. Besides this, inadequate drainage, the inefficient disposal of garbage, a lot of stray dogs, cattle, pigs, rodents roaming about and coming in interaction with humans, walking barefoot in flooded waters. All these also are important in contributing to the natural history. Occupationally, it has been understood that several occupations are more at risk, including agriculture, livestock handling, miners, abattoirs, conservancy workers in sewages, etc., poultry farmers, laboratory technicians, veterinary workers, military member staff, and those involved in fishing. Among the home and lifestyle activities, again, this can also be a exposure to pets which are infected or leisure activities like swimming, boating, kayaking, and hunting can also contribute to the development of leptospirosis. In this context, I would like to mention that during one of the floods in 2018, it was found that certain clusters were of slums or living habitats of humans were having more cases coming from these areas. And on further investigation, we found that these areas there was a lot of interaction between animals and humans. The cattle sheds were nearby to the human habitat and they were living in close association. In fact, I did take some photographs during this period and we further investigated and the link between the cattle, dogs, earlier used to be only rodents. However, these also came into problems. As I told you, certain occupations are more at risk, especially those who have come in contact with infected animals or soil or water where the bacteria is present, and those who work outdoors with animals. Coming to leptospirosis in the animals, leptospirosis can infect almost any animal, where it is harbored in the kidneys. But most commonly, it is found in rats and cattle and cows and is spread by the urine. It's not known to cause any useful symptoms, so the populations are unaffected by levels of infection. The list of animals who can develop spread leptospirosis include rodents like cats, raccoons, possums, cattle, pigs, dogs, horses, and dogs. Animals, including humans, can be divided into two types of hosts. One is the maintenance host or the carrier host, and the other is the accident host. The infection is maintained in a chronic manner in the renal tubules of the maintenance host. Other animals can get infected either by direct or indirect contact with the urine, which is infected urine of the most important maintenance hosts are small animals, which may transfer infection to domestic farm animals, dogs, and humans. Livestock farming is a major occupational risk factor for the world. Dairy farming being one of the most important in this category. And besides the urine, the genital tracts of the cattle, the vaginal discharge, the placenta of the post-pregnancy, all these also are known to harbor the organs. Thus, the mode of transmission includes indirect contact with water, moist soil, and wet surfaces which have been contaminated with the animal urine, or direct contact with urine and products of gestation and putrefaction and the placenta of the infected animals. enter the body. It can either enter the body, abrated skin, or through the mucous membranes of the eyes, nose, or drinking contaminated water can also cause infection. Outbreaks of leptospirosis are usually caused by exposure to contaminated water, such as eating contaminated food, which has the bacteria, or drinking contaminated water has occasionally also been responsible for transmission. Leptospirosis is not generally known to spread from person to person, which is a very good thing, and we're fortunate for that. How do we know that a person may is likely to have leptospirosis? In endemic areas like I mentioned earlier, all cases, especially post-flooding and post-rains, all cases of fever with myalgia and conjunctival suffusion should be considered as suspected cases of leptospirosis. Fever, which is same as in anecdotic, there are two types, the one without jaundice and the one with jaundice. Fever is same in both, and in the severe one, it may be more severe and prolonged. And another important finding in the moderate and mild leptospirosis is calf muscle tenderness. As you can see, all these in the picture here. And sometimes the patient can have headache, chills, rash, nausea, vomiting, diarrhea. And in the jaundice develops in the an icteric type of leptospirosis. So we here we have a picture which tells us the various types and various symptoms. Shows us that in the mild form we can have fever. We will definitely have fever along with body ache or myalgia. There can be headache also, which and there can be severe calf muscle pain, which is either myositis or inflammation of the muscles. And also there is another important feature called conjunctival suffusion or hemorrhage into the below the conjunctiva and redness of the eye, which is again a feature that the patient will present. And there is another phase called the leptospirotic phase, which and subsequently the severe phase. And in the severe phase, we have most likely the patient will present with jaundice or yellow discoloration of the skin and eyes, renal failure, and further on bleeding, pneumonia. It can affect any organ of the body, and which leads to multi-organ failure, and finally it can lead to death, including meningitis, eye infection, heart infection, hypotension. All these can be seen in the severe form. Following the leptospiremic phase, or the phase when it is found in the blood, there is another phase called the immune phase, and the antibodies develop, and the antibodies and the immune phase of the disease is seen. A patient with showing jaundice. This is an acute febrile illness. It can mimic very easily other febrile illnesses like flu influenza, malaria, meningitis, rickettsia, dengue, enteric fever, or typhoid. As Madam was just telling us, it can also mimic brucellosis and hepatitis and fever of unknown origin. So, it is very important to confirm the diagnosis through laboratory infection. Laboratory infections like diagnosis are very important for confirming the diagnosis of leptospirosis, and these include biochemical parameters and non-specific features like protein and blood in the urine or pus cells in the urine, increased erythrocyte septation rate, relative neutropenia or increase in platelets, and increased blood urea nitrogen, creatinine, bilirubin, and amyloid. These will point to the diagnosis of these are non-specific findings which will also point towards the diagnosis of leptospirosis. The microbiological methods include either direct evidence or indirect evidence. In direct evidence, we have the demonstration of the organism or the leptospires and its products in the samples of blood and urine of the patient. And we can also culture the sample, and which is actually a very tedious procedure and a cumbersome and laborious procedure, which is not usually followed in the laboratories. Animal inoculation can also be done, again, which is not a common practice. However, indirect evidence of include the detection of antibodies in the spice and further diagnosing and confirming the genus and the species. Here we see a common stain which is used in microbiology, not common really, but the one which is used for identification of leptospires and which is the silver impregnation method or the Fontana's method. And we can also see leptospires in the urine sample of patients and the blood also in the acute phase, which are the microscope or the dark ground illumination. There are immunofluorescent stains whereby they appear as bright color structures. However, especially in the DGI or the dark ground illumination microscopy, they can be mistaken for, along with artifacts can also mimic this, so it has to be studied with a proper technical expertise. This is the scanning electron microscopy, which is not done in the routine laboratories. What is done in the routine laboratory is the detection of antibodies and looking for agglutination in the patient's serum sample and through different tests like the leptospiratridol leptodrydol test, which was a very good test which was available during the earlier epidemics. However, it has run out of no longer being used by the company. The other tests which are currently being done is the leptospira. It's an immunochromatographic test which is called as the leptospira, which detects immunoglobulin G and immunoglobulin M against the leptospira in the patient's blood. So patient's blood sample is collected. And from the serum, this test is carried out. The presence of immunoglobulin M, which is the one which is found in the acute phase of the disease, will help to point towards the diagnosis. However, the immunoglobulin G, as you all probably know, is that it rises a little later than the immunoglobulin and stays longer. Hence, the presence of Ig immunoglobulin G will not indicate whether it is a recent infection or not. The presence of IgM will. The detection of IgM through ELISA also is very useful for identification and confirmation of leptospirosis in the patient sample. This is a date of ELISA. Another important test which has been carried out in Mumbai and have at the Kasturba Hospital, which is the reference molecular diagnostic PCR lab in the Kasturba Hospital, started carrying out the molecular PCR tests post the 2005 deluge. It was commissioned in the year 2007, and throughout the year, leptospira PCR is carried out on patients presenting with acute febrile illness. So again, a very important and useful test for confirming of diagnosis. Coming to the treatment, this is the disease may recover. The patient may recover on his own, but it is very important to treat the disease when it is mild, so that it does not subsequently go into the severe phase. The treatment for mild leptospirosis is simple doxycycline, given twice a day for 7 days, and the treatment for the mild, moderate, and the severe leptospirosis includes penicillin G, which is the drug of choice, given 4 times to the patient. Among the people who have either traveled or walked through flooded waters, or they are visiting a endemic area, then they need to take doxycycline. They can take doxycycline 200 milligram orally once a week under with the guidance of doctors. The Municipal Corporation of Greater Mumbai Public Health Department is very actively involved with leptospirosis and its treatment and diagnosis, and thus it brings out these posters for public awareness and for the doctors also guidelines for treatment of the patients. The National Leptospirosis Control Program of the Government of India, with the nodal body being the National Center for Disease Control or NCDC at Delhi, also has moved out the National Leptospirosis Control program, and the pilot study project was rolled out in 2008 and 2011 for the various states of Gujarat, Kerala, Tamil Nadu, Maharashtra, and Karnataka. It has been found to be very useful, and the objective of the project was to reduce morbidity and mortality due to leptospirosis. With the thrust areas of the project being early diagnosis and treatment, strengthening of the laboratory and patient management facilities, training of manpower, bringing out a lot of awareness material like posters and using the press and the print and both on media to increase awareness among the public and among the doctors regarding this leptospirosis. And of course, intersectoral coordination, which is what we are talking about today. Coming to prevention, the disease, the infection can be reduced substantially and prevented to a large extent with the help of personal hygiene, environmental hygiene, and provide prophylactic vaccination wherever required. And of course, chemoprophylaxis, which I just told you. The guidelines for prevention and control of leptospirosis. This booklet has been brought out by the World Health Organization, and it lays down the guidelines for its prevention. The general measures for prevention include chemoprophylaxis, especially for people who may have short-term exposures like military training or traveling or walking through flooded waters or freshwater swimming. And general sanitation approaches cannot be overemphasized. They are very important in making sure that the rodent population is kept under control, and by proper waste disposal, proper hygiene, maintenance of sanitation. Rodent control is of supreme importance, and avoidance of swimming in contaminated places. Carrying out health education again is very important in schools, in among the community, and here I would like to mention that cleaning of the and sanitization of areas with household bleach is useful to kill the bacteria. And in case the patient, anybody has signs and symptoms which are suggestive of leptospirosis, they should immediately contact the health facility so that proper appropriate management can be started. The national guidelines for diagnosis, case management, prevention, and control of leptospirosis has been brought out by the National Center for Disease Control, Delhi, and it mentions all these important aspects that people should wear if in case there is flooding and people have to walk through flooded waters, they should wear rubber boots and gloves and cover the abrasions if possible on their lower limbs and the hands, not to litter or food grain and leftover food, to keep the surroundings clean, and to prevent, to wash hands and face in case one has come in contact with dirty water, and not to use dirty water for these activities. So there is a multi-pronged, approach from all government bodies and a lot of government initiative for this. Coming to vaccines, there are two basic types of vaccines which are available, the attenuated and the inactivated leptospirosis vaccines. However, there are several problems regarding the safety, issues. Therefore, it has to be taken with caution and only among those who require it due to the professional exposure, occupational hazard, etc. Efficacy rate is known to be somewhere between 60 to 100%. Vaccination of animals, very important, is that these vaccines, they confer only a limited duration of immunity, and boosters are needed every 1 year or 2 years, every yearly or second. Vaccination should, however, be very selective and used only in endemic situations having high incidence of leptospirosis. The vaccine must contain the dominant local serovars, which is again an important point to consider. While this prevents illness, it does not necessarily protect from infection and renal shedding. There are about 10 referral laboratories in India pertaining to the leptospira diagnosis, and probably the first one was the one at Port Blair, the Regional Malaria Research Center, which is the ICMR and the government center for referral laboratory for leptospirosis. In fact, when I visited during 2010, when I was lucky to visit for an international workshop and program, this was the first time I actually saw the leptospira under the dark ground illumination, which was very interesting because although many of our labs may possess a dark ground microscope, we do not actually get to see the leptospira because it has to be carried out. It is shed intermittently in the urine, and it should be the blood also should be seen immediately, focused under the microscope immediately to actually look for these organisms which are very delicate and fragile. And so the referral, whenever there is during epidemics, the national laboratory, the reference laboratories also come into the picture, and they take large number of samples. In fact, I remember that I was closely associated with the Kasturba molecular lab during the period from 2013 to 16, and subsequently also. And during the 2018 epidemic, we found there was a lot of flooding in Mumbai, and as I told you, when I took these pictures of the close association between the cowshed and the cattle and the people living in close association, and these were then the authorities took up the case, and the team from the referral laboratory came down to collect samples and take them to find out which serovars were prevalent. And at that time, what they found is that those serovars, which are generally found in cattle and dogs, um, were predominant in the patient sample, which was not a known case till then. It was earlier thought that it was the rodents who are the ones which are involved with spread and transmission, the infected urine from rodents, whereas subsequently it has been found that the cattle and the dogs are equally important and guilty of transmission, and hence it is important to remember that there has to be good sanitation, maintenance of hygiene. The cattle shed and should be located not immediately near the human habitat. There should be some barriers so that the humans living in that area are not frequently exposed to the contaminated, infected urine of these animals. And also, it's important to remember certain take-home messages, which include sanitation and hygiene, and proper disposal of garbage, so that we do not give scope for the rodents to cause havoc. And also, it is important to remember that during the floods, what happens is that the burrows of these rodents and animals, small animals, they are flooded. So these animals come out to the land, and they contaminate the soil easily. So during flooding, wherever possible, it is important to stay away from the flooded waters and to wear the boots or the gloves if possible, and not to be exposed. And if exposed, then doxycycline should be taken as a precautionary measure to prevent the development of the leptospirosis and to prevent severity of infection. Also, it is important and to be emphasized here that laboratory diagnosis has a big role to play in the diagnosis, so that the other differential diagnosis can be demarcated, or the diagnosis confirmation will help in proper treatment. The disease is treatable, and hence it must be remembered uh, to come forward for patients, or those who are infected, or those who know who are having signs and symptoms, to present to a health center for further treatment and diagnosis. So awareness education programs are of very much importance, and again, very crucial to remember that One Health has become we cannot ignore the aspect of One Health. With this, I thank you all for a patient listening, and thank the organizers for this beautiful opportunity. Thank you all.
Thank you, ma'am. Thank you very much, ma'am, for your excellent lecture which you have given on the leptospirosis, its prevention and control. So you have covered all the sections, starting from the transmission, the treatment, then diagnosis, morphology, control of the disease, vaccines. So all the aspects, madam, you have covered in a very nice manner, and most important that you are working for so many years. You have worked on it, on leptospirosis. So, based on your personal experiences, also you have given a very excellent presentation. So, thank you, ma'am, for your presentation. A nice presentation. Now, some questions are there, madam, in the chat box. I will read it. So one of the audience is asking, how long is leptospirosis contagious
Yes.
after treatment? Hello, ma'am.
Hello. Uh,
Yes, ma'am.
Thank you for the questions. How long is leptospirosis contagious after treatment?
Uh,
Actually, it's a very good question. Leptospirosis, am I audible?
yes, ma'am. Yes, ma'am. You are audible, madam.
Leptospirosis is not known to be transmitted from person to person, which is a very good thing, and therefore the person is not contagious, and they respond very well to treatment, if especially the treatment is started at the early phase. It's very important to start treatment as soon as the patient presents and the diagnosis is confirmed. It is very important to start the treatment. Here, I would also like to add that leptospirosis, unlike other zoonotic diseases, several other zoonotic diseases, leptospirosis is not so known to be spread so regularly, or in fact, very rarely it is thought to be transmitted through food, and like I showed you, through raw milk. So it is not transmitted to between person to person, and therefore the person, once treated, um, it is for the personal recovery of the patient. Should I get tested for leptospirosis or start prophylactic treatment if my dog has it? Definitely. If a pet dog has, gets leptospirosis or shows signs or symptoms of leptospirosis, it is very important for the owner also to make sure that there is isolation of the animal, and also to take the prophylactic doxycycline. Uh,
Thank you, ma'am. Any other participant want to ask any question? You can ask directly or you can write in the chat box. Anyone want to ask? So,
Thank you
madam,
so much.
ma'am, one question, one question is there. What is roughly the morbidity and mortality in human beings infected with leptospirosis? Somebody want to?
Actually, 90% of those infected do have the very mild form of the leptospirosis. It's only in 5 to 10% that it leads to severe, and if the severity leads to severe disease, and those with severe disease, even if they are treated aggressively with the penicillin, which is the drug of choice, then even they recover, unless the treatment is started very late, in which case we may lose the patient to leptospirosis. Otherwise, it's a very treatable disease, and it's a preventable disease, it's a treatable disease. I think we all need to work together towards that. However, in a few cases with severe disease, there can be multi-organ failure and death in those unfortunate cases.
So thank you, ma'am. Thank you once again for your excellent presentation and answering the questions of the participants. So thank you, ma'am. Thank you very much from from all the team of NAHEP. So thank you.
Thank you so much. Thanks
Thank
again.
Participants, there is one announcement that tomorrow and day after tomorrow, we do not have any training lecture. Saturday and Sunday is holiday, so we will be meeting again on Monday at 11 o'clock. So please take note of it, And Monday, all of you are requested to join because attendance is compulsory for getting the certificate. So thank you. Thank you once again. Thank you to all the speakers. Thank you, ma'am. And thank you to all the participants.